Okay, so we are looking at the A-Level Further Maths, the second year mini booklet, which you should have received in the post. And I am going to have a look at this topic here, partial fractions. So let's have a look. So it says partial fractions. So you're quite used to adding fractions, algebraic fractions, to combine two fractions, three fractions. The reverse of that, where you have one single fraction, and you want to split that into two, maybe three fractions, is called partial fractions. You'll be covering it in normal maths as well, but we do three types in further maths. We only do two types in normal maths. So here, if you have a look, it says express x minus 9 over x plus 1 brackets 2x minus 3 in partial fraction form. So I'm just going to copy that out. I don't have the notes. I'll let you guys do. Okay. So I have got this fraction here, and what I'm going to do is I'm going to try and split it up into two fractions, because I've got two factors here on the bottom. I'm going to split that up as a constant over x plus 1 plus, x plus 1 plus b over the other linear factor 2x minus 3, like that. Okay, and then what I'm going to do is I'm going to times through by my lowest common denominator, which is the x plus 1 and the 2x minus 3. And if you do that with each term, then on this side, this thing here, this fraction here, times by that, the factors on the top would cancel with the factors on the bottom. So I'd just be left with x minus 9. This fraction, if I multiply this fraction by this, these two factors, the x plus 1 on the top would cancel with the x plus 1 on the bottom, which would just leave me with the 2x minus 3 multiplying the a. And then lastly, this fraction times that, the 2x minus 3 would cancel with that 2x minus 3, which would just leave me with a b multiplying the x plus 1. Okay, and then I'm going to sub in some x values. Okay, I'm going to sub in x values to make either that bracket 0 or that bracket 0. That one's probably easier, so I'm going to sub in x equals minus 1. And if I sub in x equals minus 1, I've got minus 1 minus 9, which is minus 10, would equal a times two lots of that. That's minus 2 take 3, gives me minus 5. And then you do a division, and that would give you your a. So minus 10 divided by minus 5 gives you that a is 2. And then I can sub in another x value. You can sub in an x value to make this bracket 0. So here, if you sub in x is 3 over 2, that would give you that this bracket becomes 0. So 3 over 2 take 9, which I don't know off the top of my head. This bit here would be 0, and this bit here would be b times 3 over 2 plus 1, which is 5 over 2. So let me just work this out. 3 take 18 is minus 15 over 2 is 5 over 2b. You would just use your calculator and you get your b value. So if you do that divided by that, it would give me minus 3. So b is minus 3. So that means this partial fraction, I'm just going to write it out again, will be 2, that's the a, over the x plus 1, and then the b is minus 3 over 2x minus 3. And that is the first type of partial fraction, where you've got linear factors in the denominator. Okay, so let me have a look at the next example. So we're looking at type 2 now. It says fractions with a repeated linear factor in the denominator. Okay, so I'm just going to copy this down. I have got 3x minus 1 over x squared minus 4x plus 4, and I'm pretty sure I can factorise that denominator. So I'm just going to factorise that. X minus 2, x minus 2. And you should be able to see it. You've got a repeated linear factor there. The x minus 2 is a repeated factor. Okay, so here you wouldn't just do a over x minus 2 plus b over x minus 2, because if your denominators are the same, well, you'd just have a plus b on the top line, wouldn't you? So what you do instead, you have a over x minus 2 plus b over x minus 2 squared. And if you think about it, if you were adding these two fractions, the lowest common denominator of these two fractions would be x minus 2 squared. Okay. So when you've got repeated linear factor, you write one factor and then you write the factor squared. Okay. And then I'm going to do what I did before, which is times through by my lowest common denominator, which is x minus 2 squared. Okay, so I'm going to times everything here by x minus 2 squared. And if I do that, I will have 3x minus 1 over here, because these would cancel with that. Over here, I would have one of the x minus 2 brackets would cancel to leave me with x minus 2. And this one, both of them would cancel to leave me with just b. Okay. And then just like before, I'm going to make that bracket 0. So I'm going to sub in x equals 2. And that would give me 3 times 2, 6 take 1 is 5. That is 0, a times 0, and then I've just got b, so b is 5. And then I'm going to sub in another value of x. Now, well, you don't have anything here to make 0, but you don't always have to just make the bracket 0. What you can do is just sub in any value of x. Now, the easiest value to sub in would be 0, so I'm going to do that. So if I sub in x is 0, I'll have minus 1 here. This will become minus 2a, plus b, but b is 5, so I'm just going to write 5. And then I'll just rearrange that. It's a nice simple rearrangement. Minus 6 divided by minus 2 is a is 3. Okay, so to split that fraction up, I'm just going to write it out again. 3x minus 1, x minus 2 squared is the equivalent of 3 over x minus 2 plus 5 over x minus 2 squared. There you go. So that's the second type of partial fraction. The third type is where you have a fraction with a quadratic factor in the denominator. Okay, so when you have a fraction with a quadratic factor in the denominator, then this is how you would do it. Now, this is not in further maths. Sorry, this is not in normal maths, it's only in further maths. So you'd have to set it out like this. So the linear factor, x minus 1, that is still there, but it's a constant over x minus 1. The quadratic factor at the bottom, you'd have a linear term at the top, so you'd have an x term and a constant over the quadratic factor, okay? And then you would do just like before, you would times through by your lowest common denominator, like that, and you would get 2x minus 7 is a times that, just leaves you with the x squared plus 4. This times this gives you bx plus c times x minus 1. Okay, again, just like before, make that bracket 0 by putting in x is 1. If you put in x is 1, you'll get minus 5 here. This bit here will become 5a. So that this bit here is 0 because you've got 0 times a bracket. And then you've got a is minus 1. And then you can't really sub a value in for x there because that would never be 0 because you've got a quadratic, which is always positive, add 4. So I'm just going to choose x is 0. I could choose any number really, but 0 is always the easiest one to go with. Minus 7. That would give you 4a. Now 4a is 4 times minus 1, so that's minus 4. And then over here, if you sub in 0, that bit's 0, that bit's minus 1, so you've got minus 1 times c, which is minus c. And then you can rearrange that, so if I swap these two round, I will get that c is 7 take 4, which is 3. Okay. And then lastly, I need to find what b is, so you can sub in any x value. I tend to go for easy numbers. I'm going to go for minus 1, sub it into there. You'll get minus 2 minus 7 is minus 9. That will still be 5a. 5 times minus 1 is minus 5. This bit here, just be careful now. So you've got minus b plus c. So you've got minus b plus c, which is 3, multiplied by minus 1 take 1, minus 2. Okay, and then start tidying up. I'm just going to expand this bracket. Minus 2 times minus b is 2b. That's minus 6. Rearrange to get your b. So you've got minus 9 plus 5 plus 6 is 2b. minus 9 plus 11 is 2, and then b is 1. And then you would write down the whole thing. That would give you that the original statement there gives you minus 1 over x minus 1 plus x plus 3 all over x squared plus 4. Done. Okay, so I'm now looking at the method of differences. So here you need to be able to do partial fractions before you can access this topic, which is why I've covered it. So the first part, it says express 1 over r plus 3 brackets r plus 4 in partial fractions. So this bit you can probably do yourself. It's not worth a lot of marks in further math, so you might want to pause the video and complete it yourself, and then I'll show you my answer. Okay, so here is my answer. I've got my method at the top there, and I got a is 1 and b is minus 1, and I've written it there. Okay, the next bit, it says hence. That means using what you've just done, using the method of differences, show that the sum of the first to the nth term of 1 over r plus 3 times r plus 4 is n over a brackets n plus a, where a is a constant. Okay, so it sounds really complicated, but the method of differences is not tricky. Okay, so what I've done is I've rewritten the first part here using my partial fraction, particularly because it said hence. So I've done that, I've rewritten that as that. And then what I'm going to do, it says the sum of the first to the nth term. So I'm going to write down what my first term would be. My first term, if r is 1, would be, I'm just putting r is 1 into there, I'd get 1 over 4 minus 1 over 5. So I've written that. And then I'm going to put in r is 2 for my second term. That would give me 1/5 minus 1/6. Then I'd put in r is 3. That would give me 1/6 minus 1/7, dot, 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 all the way up to the nth term, and I'd get 1 over n plus 3 minus 1 over n plus 4. Now, method of differences, you've got to spot differences. So here I've got positive 1/5. Remember, these are the sum of all these terms. So we're adding up these terms. Okay, that's what the summation symbol means. So 1/5 take away 1/5. That's just 0. So I'm just going to cross that out. And then I have got 1/6, take off 1/6. So I'm going to cross that out. And I have got, and you can see that that pattern would continue. So you'd have 1/7, when r is 4, you'd have 1/7 here, minus 1/7. So that would disappear, and so on and so forth. So this term here, so if it kept going, this one here would cancel with the one just before it, the one n minus 1. And then all you'd be left with is the 1/4 at the beginning, and the minus 1 over n plus 4 at the end. So the sum of the first to the nth term would be 1/4 minus 1 over n plus 4, which is what I've written there. And then I want it in that form. So they've asked for a specific form, which tells me I need to combine these two fractions. So I do that by timesing this fraction here by the common denominator there. And I would times this fraction here by 4, like that. Collect my like terms. And there you go. And a, you can see here, is going to be 4. And then the next bit, it says part C. Find the exact value of the sum of that sequence from the 15th term to the 30th term. So it doesn't want the first to the 30th, it wants from the 15th to the 30th. So the quickest way of doing that is say, well, if I've got the first to the 30th, the sum of all of those terms, and take off the sum of the first 14 terms, I'll get the sum of the 15th to the 30th term. So the sum of the first 30th terms would be, and I'm using that formula here that I've just worked out, n brackets 4, n plus 4, I just put in n is 30. And if I do that, I get this bit here. Take off the sum of the first 14 terms. I'm using that same formula, n brackets 4, n plus 4. You just type it into your calculator and you've got your answer. So that's your exact value. Okay, so that's that example there. The second example is a tad harder, but not much more. So this one here, express that in partial fraction form. You would have to write, so I'm going to have to do this because I've not actually done this one. So I'm just going to copy it out. So I have got 2 brackets r plus 1, r plus 2. Now you've got 3 linear factors at the bottom, which means I would split that up into 3 fractions. A over r plus b over r plus 1 plus c over r plus 2. And then just like before, I would times through by my common denominator, which would be this bit here. And I would get 2 is equal to A, R plus 1, R plus 2, plus B times R plus 2 times R. I'll just put the R in front there. Plus C times R brackets R plus 1. And then I just sub in some values of R to make some of these brackets 0. I'm going to put R as 0. And that would give me 2 is 2A. A is 1. I'm going to put in R is minus 1 to make that bracket 0. That would give me 2 is, here I've got minus 1 times minus 1 plus 2. Minus 1 times 1. That would give me minus B. This bit here is 0. You can see that. And that bit there is 0 as well. So I've got B is minus 2. And lastly, R is, I'm going to sub in R is minus 2. That would give me 2 is equal to that bit 0. That bit's 0. So I'm just left with this bit here. Minus 2 times minus 2 at 1, which is minus 1. So it's C times minus 2 times minus 1, which gives me that C would be 1, like that. So I'm going to write that all with these values in. So I have got that it would be 1 over R minus 2 over R plus 1 plus 1 over R plus 2. Okay, the next bit, so that's the first part done. So that's 3 marks there. Using your answer to part A and the method of differences, show that the sum of the first to the nth term would give you this thing here. Okay, it's worth more than 4 marks. So I'm going to use my partial fraction. So I'm going to find the sum of the first to the nth term. And I'm going to do the method of differences. I'm going to start with R is 1. And I'm going to put that in. So 1 over 1 minus 2 over 2 plus 1 over 3. I'm going to put in R is 2. That would give me 1 over 2 minus 2 over 3 plus 1 over 4. R is 3. 1 over 3 minus 2 over 4 plus 1 over 5. I'll just do 1 over 4 as well, just to make sure I've got my pattern here. Minus 2 over 5 plus 1 over 6. And then, what am I doing next? R equals, I'm going to end up with R equals n, but I think what I'm going to do is I'm going to do n minus 2. And if I do that, I'll get 1 over n minus 2 minus 2 over n minus 1 plus 1 over n. I'm going to put in n minus 1, the second to last term. That would give me 1 over n minus 1 minus 2 over n plus 1 over n plus 1. And then my final term, the nth term, will be 1 over n minus 2 over n plus 1 plus 1 over n plus 2. Okay, and then I'm going to start subtracting terms. So here, I'm going to see what I can subtract. So I can see that these all equal 0. 1/3 plus 1/3 minus 2/3. Any others that I can subtract? These ones here. 1/4 plus another quarter minus 2/4. I'll do it with a different colour. I'm not sure whether my green works. No, it doesn't. I'll go back to my red. So here, so I've got 1/4 minus 2/4 plus 1/4, and there you can see that's another 0. And you can see that that pattern would continue, all right? So that pattern there would continue, this pattern here would continue, and that one there would continue. So in terms of what's left, this is one I did earlier because it is a tricky one. Where's it gone? Okay, so in terms of what is left, I would just have this final corner left here. So this bit here would disappear, this bit here would disappear. You can see 1 over n plus 1 over n minus 2 over n, that would all become 0. So all of that is 0. All of that in between there is 0. And this bit, what have I got left? I have got left 1. I'm just going to write down what I've got left. I've got a 1. Take off 2 over 2, which is 1. And I've got a half there. And then I have got minus 2 over n plus 1 plus 1 over n plus 1. Well, minus 2 plus 1, that just gives you minus 1 over n plus 1. And then I've got 1 over n plus 2. Okay, I'm going to tidy that up a little bit. So 1 take 1, that's obviously 0. And then I've got a half minus 1 over n plus 1 plus 1 over n plus 2. So that needs tidying to make it look like their answer. So I just need to make the denominators the same. So I would times this fraction by these two factors. I would times this fraction by these two denominators there, and I would times this fraction here by these two denominators here. So I would get, over here, I'd get n plus 1 times n plus 2 on the top line, minus 2 brackets n plus 2, plus 2 brackets n plus 1, all over my common denominator of that. Expand your brackets, collect your like terms. I've done that right, 2n plus 3n. Minus 2n minus 2 plus 2n plus 2. Oh wait, that's a 4, isn't it? This one minus 4, that one. All over 2 brackets n plus 1, n plus 2. Let's see what have I got left. Minus 2n plus 2n, there we go. 2 plus 2 take 4. And on the top line, I've got n squared plus 3n, 2 brackets n plus 1, n plus 2. Okay, and that's what they wanted.